Continuing our quest to be able to write asynchronous JavaScript, we're going to take a look today at promises. I want to go back and kind of revisit the pyramid of doom a little bit, but let me first lay out a set of requirements for what we want to try to write here. And we're going to look at doing this using callbacks and see the pyramid of doom again, and then we're going to look at how do we do it using promises. The requirements then are very simple and kind of artificial, but they basically give us a set of asynchronous operations that we want to do one after the other. So first of all, we're going to create a file that just has an integer value in it. Then we're going to append to that file a second integer that's double the first, just so that there's something to write out there. Then we're going to read the file and print its contents to the standard output. And then finally, we're going to remove the file, which in Unix terms is called unlinking, and that's the name of the function call. Now, if we try to do this using the same kind of capabilities we looked at last time when we were discussing callbacks, the solution to that particular set of requirements would look rather like this. So we got this top-level function called callUsBack, just for no particular reason. And it takes two parameters, a file name and a value. So this integer value that we're going to write to the file is what's going to be passed in there as value, and the name of the file is going to be passed in as the file name. And there's going to be four operations that we're going to do here that were detailed in the previous slide. We're going to do a write file, an append file, a read file, and an unlink. And you can see that those are all methods defined in the FS, or the node file system module, kind of like read file and read file sync that we looked at previously. And there's just a whole collection of file and directory related functions defined in that package. So these all, as we talked about last time, all of those asynchronous functions take some number of parameters, and then they also include a callback function. They're going to each do something asynchronously, something in a separate thread of control that we have no real control over when it's done or how long it takes. And when that asynchronous operation is completed, it's going to call our function to complete the operation and maybe set up the next one. So for just the write file operation, we can see here that it takes several arguments: the name of the file, the value that we want to write into the file, and those are just coming in from parameters that we're passing to our top level function, and then it takes a callback. Now, we should point out again that this is going to use a fat arrow function. So anytime you see that equals greater than, you should immediately think function. What's on the left of the fat arrow is the parameter list. What's on the right of the fat arrow is the function body. In this particular case, the parameter list consists of just a parameter ERR. And because we only have a single parameter, we can lose the parentheses that usually surround a parameter list. So it kind of makes it a little more terse. Remember again that the convention in Node is that whenever a callback function is invoked, the first parameter is always going to be an error parameter. If that value is false, then everything worked okay. And if there are other parameters, those other parameters should reflect the result of the operation. If that error parameter is truthy, it's going to contain an error object that we can then use to try to figure out what went wrong and maybe recover from the error. Now, in the case of writing to a file, the only thing that's passed as a parameter to our callback in this case is that error object. There's really nothing else for the callback to receive, because our code already knows the name of the file, the content that we wrote to that file. So all the interesting things that can come back basically just consist of that error value that we want to be able to check. So the first thing that we do, so here's the beginning of that callback function. Well, the callback function actually starts here. Here's the parameter, and the body begins here, and it actually extends all the way down to here. So this entire function, callUsBack, is almost completely dominated by the callback of that very first asynchronous function call to fs.write file. Like we saw before, when we are processing a callback, the first thing we're going to do is check the error argument. So we see here if error, if the error value is truthy, then something went wrong, and again, I'm just kind of finessing this case by saying, well, I'm just going to print an error message out and then skip the rest of the code in this function. So console.error, writing value to file resulted in this error. Notice again, I'm using the back-quoted template literal here so that I can simplify the construction of that message. And then every place where I want to include a particular value from an expression, I use the $curly and close curly again. So if this write fails, we're going to just print that error message, and then the rest of the function body will be skipped because it's all in an else clause. Okay. That's the first step in the asynchronous chain of operations that we're going to do here. Now, I've got to make sure that the next asynchronous thing that I do is inside this callback function. If I put it outside the callback function, then as soon as this fs_write file would have gotten called, it returns right away, remember, having spun up a separate thread to do the asynchronous stuff, and then it would immediately execute the next instruction in my code. Well, if I'm depending on the fact that that first asynchronous thing is going to complete, that's not the way I want to code this. I don't want the next asynchronous thing to run before the previous asynchronous thing completed. But by the very nature of an asynchronous operation, I don't know when that asynchronous operation is going to be done. I don't know how long it's going to take for Node to start up access to the file system and create this file and write something to it and so forth. So the only way that our code knows that that's complete is when this callback function gets invoked after the file has actually been opened and written to. That being the case, all of the other steps that I'm going to do here need to be inside the callback. It's hard to overstate the importance of that idea. Once I've done an asynchronous thing, if I want to do another asynchronous thing using this callback paradigm, I've got to stay inside the callback. It's kind of like the Yoda's proclamation that once you turn to the dark side, forever it will control your destiny. Once you start down this path of asynchronous behavior, you pretty much are stuck there, because there's not really a convenient way, at least with callbacks, to sort of get back outside of that asynchronous behavior and wait for everything to complete until you can go on to the next step. The only way to do that is to make another callback inside of an asynchronous callback and another callback inside of that one. And that's, of course, what gives rise to this pyramid of doom shape that we're seeing here. Okay, so in the else clause, and again, I'm still inside that outermost callback function, the function that's indicated by the fat arrow there. The next step I'm going to do is take the same value that I wrote to the file previously and double it and append it to the file. Again, there's no particular rhyme or reason to this. I'm just trying to stack up multiple asynchronous operations. So I'm going to double the value that I passed in, and then I'm going to do another asynchronous function, the append file function. And similar to write file, it takes the name of the file, the content you want to add to the file or append to the file, and it also takes a callback function. So the second callback here that's nested inside the first one starts here. It's a fat arrow function, and it extends all the way down to here. So the rest of everything in this top level call us back function is contained in this callback. Again, we're going to just get an error parameter, just like we did with the write file case, because we already know everything else that's going on with respect to the append file. All we need to do is be informed of whether it worked or not. And if it didn't, then error is going to be truthy. So we're checking to see if error, and again, outputting an error message that gives us some idea about what was going on when an error was detected, and then the rest of the function will be skipped because the rest of it is all inside of an else clause. So now we've got kind of two asynchronous operations that are happening one after the other by merit of the fact that the second one can't start until the first one is done and calls its callback. We're going to repeat that pattern again. The third step in the requirements was to read the contents of the file and show its contents on the output device. So now we're going to do the read file, which we've already talked about in a previous lesson. We are going to pass in the name of the file, the encoding for the character data in that file. So this is just the Unicode encoding. Don't worry about it if you don't know what that is. And then the third argument is a callback. So here's our third callback nested inside the second, which was nested inside the first. And that extends from here all the way to here. You can see that it's a fat arrow function. We know that the parameters are on the left of the fat arrow and the function body starts on the right. And in this case, as we discussed before, we're going to get some additional or an additional parameter besides the error. So again, node convention, not required by JavaScript or anything like that. It's just the way Node does it. The first parameter is an error parameter, and then any additional parameters provide any additional information to the callback. We're going to check to see if the error is truthy or falsy. If it's truthy, then something went wrong. We print an error message and then skip the rest of this function in the else. But if it worked, that is, if the read file asynchronous operation completed successfully, then the data parameter being passed to us is going to have the contents of that file. So we're going to finally print out the contents in this console.log statement. Now, that being done, we're going to do the fourth operation in our requirements, and that was to remove the file, which is done with an operation called an unlink. That's a Unix term that's found its way into Node. And the unlink command takes as parameters the name of the file that we want to unlink, get rid of, and then a callback function. So our fourth and final callback starts here. There's the fat arrow declaration, and it ends down here. So if we can successfully remove that file, the error value will be falsy. We'll skip over this error message, and we'll print out another string to the console that says completed. Now, that obviously works. I mean, this does those four operations. It does them reliably. It makes sure that errors are being at least reported, if not handled. And it also works properly with the asynchronous nature of these individual function calls by merit of the fact that each of the succeeding calls is invoked inside the callback function from the previous one. But as you can see, just by the very nature of this sort of pyramid on its side structure, that it gets kind of tedious to deal with all of these function calls and doing the error handling the way we're doing it. And if we have to do something more complex, it just gets worse. So we're hoping that we can find another alternative than using callbacks like this and ending up caught in the pyramid of doom all the time. Now, just to show you what this does, now that we've gone through the whole thing, we're going to invoke call us back. That was this top level function here, and we're going to pass in the file name and the value. So there's the file name, there's the answer to life, the universe, and everything. And the output that we get back is 4284 and completed. So the first thing that this call us back function did was write 42 into the file. When that succeeded, it appended twice 42 or 84 in the file. Then it read the contents of that file and finally printed out here in the console.log statement, it printed out this first line of the output, 4284. After that, it went on and removed the file, and because that succeeded, it finally executed this statement, and we see completed showing up in the output. So that's working successfully, but I think you'd have to agree that the implementation of this was a little bit painful. The focus of this talk is the notion of promises. So this is a new way of kind of wrapping up this asynchronous behavior in a way that short-circuits some of the shortcomings that we saw with the Pyramid of Doom implementation. So let's talk about what promises are. Now, I want to first introduce a kind of an analogy to this. We'll see that the goal here is to have an alternative to callbacks to be able to do asynchronous computation without all this pain. But as an analogy to kind of wrap your head around a little bit to try to understand what these promises are about, I would like you to think about ordering food at a fast food restaurant, so Wendy's, let's say. That was my very first job when I was in high school back in the early 1820s. So when you go up to the counter at Wendy's, what you do is you, first of all, place your order, and the person at the register keys it into the register, and you pay, and out pops a receipt, a piece of paper, that the person that took your order hands to you. Now, you could think of that receipt as a promise of a future meal, right? You generally have to wait a little bit while they prepare your sandwich and your fries and your drink, but you're sort of assured by merit of the fact that you have this paid receipt in your hand that you're eventually going to get your meal. You don't get it right away. You get a promise of a meal that's coming, the promise of a future meal. Now, later on, after the kitchen gets done constructing your order, you're going to be notified of the availability of your order. Maybe they call your number, or they call your name, or they just know that it was you that ordered it, and they point at you and say here's your meal, and hand you the tray. And the other possibility is maybe you ordered something on your meal that had the previous customer got the last one, right? The last chicken sandwich or whatever it was. So it's also possible that you might have paid for that meal and received the receipt, but after a little while learned that that order was not going to be completed, that there was no way for them to fulfill that order because they were out of stock on something. So 2 possible outcomes from this process. Now, there is a almost direct analogy between that fast food ordering process and the use of a promise in asynchronous coding. So the equivalent of placing the order is effectively calling the asynchronous function, right? You're sort of starting up a process that goes on behind the counter outside of your direct control, but your presence at the register is the trigger that causes that behavior to start, okay? After you make that request, after you call this asynchronous function, what you're going to get back pretty much right away in comparison to the overall time it's going to take to complete this asynchronous operation, what you're going to get back right away is called a promise. Now, it's a little odd to use that term in this sense. So, as usual in computer science, we have lots of goofy ways of using the English language or other languages. But the promise itself is just a JavaScript object, right? So it really is quite similar, or it's quite analogous to the notion of this physical receipt that you receive from the order taker. You're going to now have in your hand, or your program is going to have in a variable someplace, a promise object that it can then use to do other stuff. There's 2 outcomes at the end of this process, right? You'll have that promise object. Because this is an asynchronous operation, your code's going to continue to do whatever it does until such time as your code decides to wait for the result of that asynchronous operation. Just like, you could grab that receipt and you could head to the restroom for a few minutes and come back out and you'd still have the receipt. You could still pick up your food, right? Even if you did other stuff in the interim while the kitchen was preparing your meal. And again, there's 2 possible outcomes. Either that asynchronous operation completed successfully, which would be the equivalent of, here's your actual meal as you ordered it. And at that point, the promise would go from this sort of state of waiting to be completed or pending into a state that we'll call fulfilled, right? The promise has been fulfilled in the same way that your meal order has been fulfilled by the kitchen. The other possibility is that something might have gone haywire in the process of executing that asynchronous operation that's represented by the promise. In that case, we'll say that the promise was rejected in the same way that if the kitchen doesn't have the necessary ingredients to make your sandwich at the restaurant, they're going to say, sorry, we can't give this to you, so they can reject your order. So very similar kind of a process. Make the request, get back a promise, then sometime later, the promise is going to go into one of 2 states, either fulfilled if the asynchronous operation worked, or rejected if the asynchronous operation didn't work. So some characteristics of this in practice. First of all, we'll see that this is way easier to use than callbacks. It doesn't tend to create that kind of pyramid of doom structure that's really hard to write, to debug, to do error checking, and so forth. We'll see that it's sort of easier to chain together multiple asynchronous functions, one after the other, than it is when we try to write the pyramid of doom. And then the error handling is also quite a lot simpler in that we can check for errors if we want to. We don't have to. We can wait to check to the end to check for errors until the end, and we'll look at some examples of how that works. But at the end of the day, we're still going to do an asynchronous operation, and some code of ours is going to be invoked when that asynchronous operation completes. And we could go on and do more asynchronous operations in series at that point. or maybe that chain of asynchronous operations is done and we can go on and do something else in our code. Let me give you a little preview of what this is going to look like and explicitly compare it to the idea of callbacks. This is a simple, just generic function that illustrates the use of callbacks as we've been doing it so far. The top level function is called async func1, and it takes some arguments, and its final argument here is a callback function. You can tell it's a function because of the fat arrow. Here's the arguments to the function, and then the function body extends down to here. If that async func goes haywire, at least if it follows the convention that's been established by node, the error parameter will be truthy, and we'll check to see if there was an error, and if there was, we'll handle the error. Otherwise, we'll go ahead and take the else clause, and now we're going to call a second asynchronous function. So we're chaining these async functions together. Here's async func2, and I'm just assuming, for example, that we're going to pass in the result from the first function as one of the parameters in the second one. And then it's going to also take as its final argument a callback. Here's the callback function from here to here. And you can see that it's a function by merit of the fat arrow. And we're going to do the same thing. If there was an error passed back by the async func, we're going to handle the error. Otherwise, we're going to process the second result that we get back, and so forth. And as you can tell, we could continue to nest this. But so I want to compare that with a similar schematic implementation that uses promises. You can see right away that there's a lot more. There's a much more simple flow here to the progress of these function calls. We're calling async func1. We're still passing it a couple of different arguments that it needs to do whatever it does. But instead of passing a callback function as the last argument, we're going to call this weirdly named method called then. And what then does is basically says, hey, let's wait until the async function figures out whether it worked or it didn't work. And then depending on what happened, we're going to call another function. Keep an eye out for the fat arrow, right? There's a function, there's a function, there's a function. And you can kind of maybe see now what's going on behind the desire to have a simpler syntax for functions, because in this type of programming, we're going to use those guys a lot. But you can see here that the then, which sort of implies, sort of temporal, right? We're going to do this, then we're going to do this next thing. So the then clause takes a function, it's a fat arrow function, and it's basically the callback, right? It's our code that we want it to run when the first asynchronous function completes. That's exactly what's going on up here in the callback version. Async func1 is going to run first, and when it completes, it's going to call this next piece of code. In our case here, we're just going to call async func2, just like we did up here, and that's also going to yield either a successful or a failed attempt to run a function. And if the function runs successfully, we're going to take the next then. And here, we're going to do something with the results that were returned by async func2, just like we would have here inside the callback formulation after async func2 returned and didn't send us any kind of an error. Then finally, you'll notice that these two then methods are basically the code that's called if everything works. We can actually put together all of the error handling in one spot in this paradigm, where we use this other weirdly named method called catch, which is intended to kind of connect to the try-catch sort of idea in synchronous coding. And the catch method will be invoked if anything goes haywire in any of those previous steps. And what will happen is the catch method will contain a pointer to a function again. Here's that fat arrow function. It's going to get the error value that was generated by wherever this went wrong, and then do whatever it is we're going to do to handle the error, just like we sort of indicated up here. Okay, so we got all the same behavior. We are still retaining the ability to wait for one asynchronous function to complete before we run the next one. We still have the ability to pass in our code to be executed when the asynchronous operation is done. But we get a quite a lot simpler syntax. We can chain things together with just .then, and .catch. We don't have this pyramid of doom anymore, or callback hell as it's sometimes called. And it's a lot easier to deal with errors, as we can see here. In this case, we've kind of just finessed all the errors into one single catch method call. And we can be more subtle about that if we want to, but this is a quite common pattern to just sort of, if there's a problem at any time in the chain of .thens, the .catch will be invoked and our error will be handled or reported or whatever. So the next step here is to kind of figure out, well, what are all these things doing? What is then and catch and all that kind of stuff mean? But I think you'd agree that it's probably worth going down this path, because this nice chaining of .thens is way simpler than getting stuck inside the pyramid of doom. So as you can see, a promise is an abstraction of this notion of how do we invoke callbacks and that kind of stuff in the face of asynchronous execution. So I want to talk a little bit about some of the terminology that surrounds promises. Let me just remind you again, as I said before, a promise is just a goofy name for an object in the JavaScript code. There's nothing magic going on here. There's nothing super obscure that has to be done to be able to make this thing work. A promise is just an object. Now the cool thing about it being an object is that you can store it in a variable, you can pass it to a function, you can store it someplace and come back to it later. That actually has a lot of advantages in terms of engineering code that uses asynchronous behavior. But at the end of the day, it's just an object. So when we're talking about, on this slide, when we're talking about the states of that object, we're just talking about basically a value, an enumeration or something that's inside that promise object that can change values. And this is the way the promises behave. But no magic, it's just ordinary JavaScript. So the illustration here shows that a promise object can be in one of three states. It can be pending, which is the state it's always in initially. When we first get that promise, this is the moral equivalent of getting the receipt back from the cashier at Wendy's. You're in a pending state. You haven't yet learned whether you're going to get a meal or not get a meal. You haven't gotten the meal or gotten rejected because something was out of stock. You're still pending. You're waiting for the promise to resolve. After being in the pending state for a while, it's going to become, or the promise is going to transition to one of two states. Either the fulfilled state, which would be the case if the promise worked successfully, or if the underlying asynchronous operation worked successfully. Or in the fast food analogy, it's when you actually got the tray with your meal on it. You might also, though, go from the pending state to the rejected state, which in a promise would be the case where something went wrong with the asynchronous operation, and you want to know about that so you can handle the error properly. This would be the case in the fast food analogy when the grill person told you, sorry, we're out of hamburgers, and you're not able to get a meal. Now, in the generic term for these two states, fulfilled and rejected, is called settled. So at the beginning, when a promise is created, it's in a pending state, and eventually it's going to transition to one of the settled states, or the promise is going to settle, is the way it's talked about, and it's going to settle either in a fulfilled state or a rejected state. There's no other possibilities, and it's important to note that once a promise makes the transition from pending to fulfilled or pending to rejected, it stays there for good, which we'll see in a little while is a really handy behavior, because we don't have to kind of go back and second guess, does the promise said it was fulfilled, but now it's rejected. That's just never going to happen. It's going to go to one of those states and it's going to stay there. So just to highlight again, we're always in one of these three states. Either the result is not ready, or fulfilled, the result is available and the asynchronous operation worked, or rejected, something went haywire with the asynchronous operation. So when everything's done, the promise goes into that settled state, one of those two, fulfilled or rejected, and once it gets there, it never changes again. All right, so one of the things that we'll see here is that when we use promises, we might be actually using, and we know that there's a huge ecosystem of modules associated with JavaScript that come from like the npm.js repository. A lot of the packages that are out there already use promises, and we can just kind of rely on the implementation being done properly, and we can use .then and .catch and go about our business fat, dumb, and happy. On the other hand, there's a bunch of asynchronous code out there that still uses callbacks. And in order to be able to use those callback style asynchronous functions in the context of promises and to get all the advantages of promises that we've been discussing, we have to be able to sort of convert from that callback-based behavior into a promise-based behavior. And this process has an extraordinarily awkward name. It's referred to as promisification. So we're taking some callback code and we're turning it into code that uses promises that we can then take advantage of elsewhere in our application. So this is kind of a schematic view of how we take a function that is callback based and turn it into something that behaves like a promise. So the code here is using, so this is, again, ordinary JavaScript objects. There's a class defined in JavaScript called promise. It is a promise object. It's just an ordinary JavaScript object, like I said before. No magic going on here at all. So what we're trying to do here is create a new promise that will wrap up the behavior of some other style of programming like callbacks. So we're going to call the constructor, the new function, on that promise object. And what we pass to promise, as you may not be surprised, is a function. Now, that function is called the executor or executor. I don't know, however you want to pronounce it. Depends on which part of Indiana you're from, I guess. It's that function that is going to essentially interpret the behavior of the underlying thing that we're wrapping up in a promise in terms of the promise's semantics, in terms of the way promises behave. So the promise constructor takes this executor function, and inside of that function, it's up to you to basically do that asynchronous thing, okay? And I've left out the details here by just saying do something asynchronous. You then need to determine, did that asynchronous behavior work as expected or didn't it? So we've got a kind of a similar error handling scheme as we've had previously when we were talking about callbacks, which shouldn't be surprising, right? Because very often when you're promisifying something, it's a behavior that's based on callbacks, and you're trying to wrap that up in promises. So if, and I've just said, if it worked, if the asynchronous thing worked, super generic idea here, what we're going to do is we're going to call a function called resolve, and we're going to pass to that function the value associated with the underlying asynchronous thing working. So if we think about reading from a file, the result from that working properly is going to be the contents of the file, right? So that file contents we could pass as this argument to the resolve function. Now, what in the world is the resolve function? Well, this is something that's passed to us when we construct this promise, right? So the promise constructor that's being called here expects to get a function. When we call that function, when we ask that promise to do something, one of two things is going to happen. If the underlying operation worked, we want to tell the promise that's wrapping us up that everything went well. And we do that by calling the function that the promise constructor gives us, right? We're sort of trying to tell something back to the promise, but in order to do that, the promise gives us a hold of this function that says, hey, when you detect that everything worked with that asynchronous operation, call this function, and that's going to allow the promise to change state, right, to do this transition appropriately, say from pending to fulfilled, and then carry out the rest of the behavior that promises do, as we've been talking about already. On the other hand, if that underlying asynchronous operation goes wrong, instead of calling the resolve function, we want to call the reject function. And we're going to pass to that reject function a parameter that's usually called reason, right? The reason for the failure. And often that's going to just be a JavaScript error object, right? Just as we've seen with the callback code in Node, that error object is the thing that you would pass as the first parameter to your callback. And again, this reject function is being given to us by the promise, right? When we construct this promise object, it's eventually going to call this function that tells us, hey, if you want to indicate to me that this underlying thing worked, call the first function called resolve by default. If you want to indicate to me the promise that the underlying asynchronous function failed, call the second function called reject by default. Notice that these are just ordinary identifiers. We could call this A and B as long as we called A here and B here. It doesn't matter what those things are called, as long as we obey the semantics of the way that this function is defined. And that's to call the first function with the value if it worked, and the second function with the error if it didn't work. Okay? So that's the promisification process. We're taking some other code, some other paradigm for asynchronous operation. We're wrapping it up inside of this constructor that's creating a new promise, and we're reinterpreting the behavior of that asynchronous function in terms that the promise understands. Okay? And we do that by invoking either the first function that it passes us or the second function that it passes us to tell the promise, hey, we went from pending to fulfilled, or we went from pending to rejected. So our focus here has been on creating a new promise object and giving it the appropriate information to behave appropriately based on some underlying asynchronous operation. So you can see here that this slide is entitled Creating a Promise. So that's how you would create code that will return a promise. We also want to know kind of how do we use that promise. So consuming a promise is going to use the same kind of syntax that we were looking at in that earlier example. So recall that the promise that we created is being stored in this constant called vow. I guess that's a type of a promise, right? So when I want to use that promise, when I want to trigger that asynchronous behavior, I'm going to just call functions that are defined on vow. Now remember, back here, when we created this promise, vow is assigned to be a promise, right? So the type of this is promise. It's a promise object in JavaScript. And the promise object defines some methods. Just like any other class in any other object-oriented language, there's some methods that are defined on that promise object. And the two most important are then and catch. Now they're weirdly named, but you'll kind of get the sense of why they're called that, because it sort of makes the code more readable and kind of flow nicely. So when we call this vow, when we call the .then method of this vow object, what happens is we execute the code, right? That triggers this asynchronous behavior behind the scenes. That asynchronous behavior does something and eventually gets to the point where your promisification code can interpret whether it worked or it didn't work. And then you call either resolve or reject, depending on whether the underlying operation worked or didn't work. If behind the scenes your promisification code calls resolve, right, the happy case, what happens is the then method will invoke this function, right? So this is your code that's going to be run in response to the successful completion of an asynchronous operation. That's exactly the same thing as your code being passed as a callback in the callback paradigm. You triggered this asynchronous operation by calling .then. Behind the scenes, that asynchronous operation was executed, and you checked to see that it worked properly and called resolve. That call to resolve tells the promise, hey, go ahead and run the code associated with a .then method, and it's going to run this code. Furthermore, you want to get access to the data that was being returned by the promise's successful completion, for example, the contents of a file that you might have read, and that's going to be the value that you pass here to the resolve. That's going to show up as this parameter, right? Again, this is a function, fat arrow function, parameter on the left, body on the right. The parameter that you'll be passed is going to be whatever your promisification sent to the resolve function. On the other hand, if when you invoke that .then something went haywire, in other words, something in the execution of your asynchronous function didn't work, you will have detected that and called the reject function. And that will cause, in the promise, this function that's associated with the .catch method of the promise to be executed instead. Furthermore, just like the value is passed in the successful case, the reason that you created here in your promisification is going to get passed to the catch clause or the catch method and sent in as the parameter of that callback function that you're providing inside the .catch. It's important to note here again that the promise, once it settles in either in either fulfilled or rejected, once it settles in one of those things, it never changes condition. That's really cool because in many cases, what you're going to do here in the .then clause is another asynchronous operation. And you want to be sure that the previous asynchronous operation has completed, has gotten into a settled state before you try to do the next thing. Now, because this is asynchronous, right, we don't have any guarantees of the timing of this code. It might be that you're going to call the next step before the promise settles. Well, if that's the case, the promise object will wait to call your code until the promise settles one way or the other. On the other hand, you might call your code or try to call your code after the promise settles, because the promise settled right away and then you went off and did some other things and then did a .then. Well, in that case, the result from the promise is going to be stored away by the promise mechanism, and when your code finally does run, it's going to be notified of that cached value. So no matter what ordering takes place here between the asynchronous operation and maybe your main thread of control, everything's going to still work properly. So the promise, although you can find implementations of these promise classes out on the internet, and some of them are actually quite brief and reasonably comprehensible, but they have to be very careful to get these semantics exactly right to allow for cases of out-of-order completion of the asynchronous tasks that are taking place. The good news is, if you just use the promise object, you don't have to worry about all those details. It's instructive to take a look at them if you're interested, but in practice, you just rely on the behavior doing the right thing. Here's another illustration that tries to bring all these pieces and parts together in how promises work. So we can think of two participants in this promise operation, sort of the creator of the promise and the consumer of the promise. The creator's job is to take the asynchronous function, invoke it, and then interpret the results in terms of whether the underlying asynchronous operation worked or failed. If the asynchronous operation worked, the creator is supposed to call resolve. If it failed, it's supposed to call reject instead. Depending on which of those two functions that are called by your promisification code over here, the promise itself is going to switch from the pending state to either the fulfilled state or the rejected state. The consumer then, the code that's calling .then or .catch, is going to have the appropriate methods invoked based on whether the promise transitioned from pending to fulfilled or pending to rejected. If it went to fulfilled, then on the consumer side, the then method is going to get invoked, and we know that the then takes a function. That function is going to get the data that was passed into the resolve method by the creator, and then it's going to be executed. It's effectively a callback function. It's your code that runs after the promise resolves to a fulfilled state. On the other hand, if the promise is rejected because something went wrong here in the async function and your promisification code called reject, the catch method is going to be called on that promise object, and it's going to be passed whatever value you sent in as a parameter to the reject function after you detected that there was a problem on the creator side. Let's talk a little bit about promises and the Node ecosystem. We know that there's a ton of these modules that have been already created for Node. A very large number of them use callbacks because that's the way Node's designed itself. Node has started to support promises in fits and starts, so a lot of Node code and a lot of the modules that have been written for Node don't yet use promises as native things. So it's helpful for us to know, how do we take an asynchronous function in Node and wrap it up in a promise, promisify it, in order to be able to use it with promises. So here's an example of promisification. We've got, I'm basically taking and I'm wrapping up the read file method inside the fs module in Node, right? We've been seeing this for several days now. To read from a file, we call this fs read file, we pass in a file name, we tell it the Unicode encoding, and then we pass it a callback function that interprets the results of that asynchronous operation. That's all fine and good. What we want to do here is create a promise that has the same behavior as the underlying fs read file, so that we can use that promise elsewhere in our code and realize all the benefits of having promises. Now, this is a critical idea. If you take nothing else away from this talk, this should be it. The goal of this promisification is to take an existing asynchronous piece of code and interpret its behavior in terms of promises. So in this case, we're going to take that fs read file, we're going to call it like we normally have, but instead of sort of doing stuff directly with those results, we're going to wrap that behavior up in the semantics of a promise so that we can use that promise elsewhere and take advantage of all the conveniences that a promise provides without having to monkey around with the underlying fs read file. Okay, so as we saw earlier, when we're promisifying something, the principal goal is to create a promise object. So we've got this new promise here, just like we saw before. Previously, we were storing that in a variable and then reusing it. But in this case, the goal here is to give back a promise that wraps up the read file function. So we're going to call that same constructor, and in this case, we're actually going to return it from this top-level function. So to kind of mimic the convention that Node uses for naming these modules, we saw that fs read file was going to be an asynchronous read file. We also took a look in the early going at fs read file sync, right, which was a special implementation of read file that operated synchronously instead of asynchronously. So I'm kind of following that pattern and saying, okay, let's call this fs read file promise, because it's the promisified version of read file. It does the same thing as read file does under the hood, but it gives us the promise semantics from the point of view of the code that's going to call it. So the goal of this promisification function, fs read file promise, is to create a promise and return it to the caller. And that's exactly what the first part of this function body does. Return this new promise. So that's kind of just boilerplate code that we always are going to see something either identical or very similar to that in our promisification functions. What we've got to do specifically for this particular asynchronous behavior is interpret the behavior of the underlying async thing, the read file in this case, in terms of the promise's semantics. So we call fs read file, we pass in the name of the file we want to read, we give it a default encoding in this case, and then this read file function, that hasn't changed. It still relies on some parameters, including a final parameter that's a callback function, right? So this error comma data thing should look very familiar from previous examples. This is a function, it's a fat arrow function, and now instead of actually handling the result of reading the file, we just want to reinterpret this so that the promise that we're returning will behave properly for our code that's going to use this. Well, just like before, we're going to assume that Node will pass us an error object if something went wrong. So the first thing we're going to do inside of the body of this callback is check to see if error is truthy. If it is truthy, we want to call this function that the promise constructor is going to pass to us, and the job of that function is basically just to inform the promise, hey, something went wrong, you should change state from pending to rejected, and then let the code that's using you know about that by calling the .catch method. So what we're doing inside of here is invoking reject, and in this case, I'm just going to pass along the error value that Node gave me, right? I know that that's going to be a standard JavaScript error object. I'm going to just hand that along so that the code that's using the promise inside of its .catch method can just refer to that error object and figure out what to do next. On the other hand, if the error value that was passed to my callback was falsy, I'm going to take the else clause and I want to call instead the first function passed to me as a parameter in this constructor, which is the function that the promise object itself implements to let it know that everything worked with the underlying asynchronous function, and also gives me a way to pass additional data that's going to end up being given to the function, or that's going to be given to the function that's invoked by the promises.then method. So I call resolve, and I pass in data, which is the second parameter here that I got in my callback, right? That's the contents of the file that was read. I call resolve, that tells the promise to switch from pending to fulfilled, and also tees up this data as the information that will be returned to the function invoked by the .then method of the promise itself. And that's the end of this promisification function. Again, what comes back from this guy is a promise, right? It's a promise that knows when it's invoked how to call read file and how to interpret the results in terms of the semantics of promises. The final little piece here that I didn't point out, but I want to make sure you're aware of, is that we are passing a parameter to this promisification function. We're telling it which file do we want to read. The promise itself and the underlying read file method that's defined by node don't know which file we want to read, so we've got to tell it that when we invoke this promisification. And that's just passed directly to the read file function so that it knows which file to read. How do we use this? Well, here's the example. So here's our read file promise function, and it needs to get the name of the file that we want to read from. And I'm wrapping, just for convenience, I'm kind of wrapping this up in another top-level function that's going to basically be responsible for invoking read file and interpreting the results. So fs read file promise, this gives us back a promise object that's configured properly to interpret the behavior of the underlying read file method in Node. If that file is read successfully, as we saw back here, we're going to get a falsy error value, and that's going to cause the resolve function to be called with the data that was read from the file here. So that's on the creator side. On the consumer side, which is where we are here, that's going to result in the promises then method being called, and the result, the behavior there is going to be to call this function. So again, as is always the case here, we're doing something asynchronous, and eventually our code gets called when that asynchronous thing is over. Now, I'm not doing anything particularly interesting here. I'm going to get that data parameter that's been passed up from inside the promisification function, and I'm just going to log the data to the output device, the standard output. On the other hand, if the promisified read file fails, then I'm going to get an error value here that's truthy, and that's going to say something went wrong, and I'm going to call the reject function, which is going to result on the consumer side of the .catch method being invoked on the promise object. And I'm also going to receive the value that was sent in as the parameter of this reject function. I told the promise something went wrong. Let my user know that here's the reason something went wrong. And so that when the catch function or the catch method of that promise object invokes this function, it's going to pass that same object in as the parameter of this function. Notice again, these are fat arrow functions, right? These are functions that are going to be called by the promise in response to the promise going to a fulfilled or a rejected state. And again, in this case, I'm just printing out the result to standard out. Now here's two instances of invoking this invoke read file function. In the first case, I'm going to read a file called datafile.txt, and it turns out that on my machine, when I created this slide, there was in fact a file called datafile.txt that contained this content. So what we see in the output here, as a result of this first invoke read file, I passed in datafile.text. I invoked the promisification function to create the promise. So this thing returns a promise object, and that promise object has defined on it a .then and a .catch method. Because the underlying asynchronous code that calls Node's read file function works in this case, the .then method is used to invoke my success function, right? The function of my callback essentially, that I want to have invoked in the case that the async behavior worked. And so it just logs that data out to the standard output. I also wanted to illustrate the notion that that we can deal with errors in this way as well. So in the second instance of invoking the invoke read file function, I'm passing in the current working directory, just dot, right? Says this is the current directory. Well, read file is defined in Node to work on files and not on directories. There's a set of directory functions as well, but read file won't work on a directory. So what happens is the underlying read file gets called on that directory. That results in an error that's reported by Node giving back a truthy error parameter in the callback, which calls reject, which tells the promise object, go ahead and tell the calling code something went wrong and hand along this error object as additional data. So that results on the consumer side of the catch being invoked, and the catch is going to run this function that I've passed in and hand me the error object that's then going to be displayed here in the standard output. So the error itself, E is dir, that's kind of the standard Unix error message that says, hey, what you've asked about is a directory, is dir, and that doesn't work with this call. To wrap this up then, let's go back and take a look at how we might re-implement the code at the beginning to avoid the pyramid of doom. We've already seen this example of promisifying the read file function, and we know that pyramid of doom example also wrote a file, appended a file, and unlinked a file. So because, again, Node doesn't expose a promise-based interface for those functions, we need to provide wrappers around them to promisify them. And I've included here for completeness, and I'm not going to go into these in a lot of detail because they all look very similar to the read file case that we looked at in detail. But this is the promisified version of FS write file. Takes the file name and the data that we want to write to the file, and under the hood, it's going to cause write file. It's going to call write file, and it's going to pass in the file and the data to be written there. And as we saw previously, write file's callback in Node just has a single parameter, the error object if there was a problem. And exactly like before, if we have an error object, we're going to call reject and pass the error value. If we don't have an error, we're going to call resolve. In this case, there's nothing really to pass back as the data associated with the .then method, right? Because we didn't get anything back from write file. So we're just passing an empty argument list to invoke that function as part of resolving the promise. Here's append file. Looks exactly the same except for the word append instead of write. Going to take a file name, the data to append to that file, call append file behind the scenes, pass in the particular values we want to append to the file, and process the error to call resolve or reject. Again, this is promisification, taking an asynchronous function, in this case fs append file, and interpreting its behavior in terms of the semantics of promises. That's the whole game with promisification. Finally, here's the unlink. The unlink takes a file name and calls fs.unlink on that file. Everything else is exactly analogous to the other examples. Finally, here's how we would call those promisified functions using the promise interface. So I've got a function here called make a promise is my top level function. It takes a file name and that initial value, just like the pyramid of doom version. And then we're going to call a succession of those functions. So fs write file promise, that's the thing that wraps around write file. It takes a file and some content to write into the file, and it does that write. When that thing is complete, it's going to, if everything succeeded, it's going to call the then method on the promise that was returned by that function. the next thing that's going to happen then is that we're going to call this function, our code again, that's going to be invoked after the asynchronous operation is concluded, and we're going to run that function. Now keep in mind that although the write file promise doesn't really give us back anything useful, right? Remember that back here in the promisification of write file promise, we actually just returned nothing, or we called that resolve function with no additional information. We still have to pass a function in the .then method. In this case, the function, and again, there's the fat arrow, the argument list is empty, right? Because fs write file promise returned back to the calling code without returning a value. The argument list of the resolve was empty. So we don't expect to get any value here that we're going to pass into fs append file promise. So that's totally fine, but we still need to make sure that we have a function there. And I don't know if we've seen this before or not, but when we have a fat arrow function that has an empty argument list, we still have to put something to the left of the fat arrow. And in this case, we're just going to put in the empty parens. It's only in the case that we have a single parameter being passed to that fat arrow function that we can get rid of the parentheses. If we have 0 arguments, we need them. If we have 2 or more arguments, we need the parens. It's only if we have 1 that we don't. So the next step then is to call that promisified append file, same file, and append the value times 2. That similarly doesn't return anything of interest, so we've got our next then clause, and the argument list is empty, and we're going to call read file promise, which is going to now reopen that file and read in the values. And of course, the read file does return something. We do pass the data that was read from the file into the resolve function inside the promisification. So this guy returns a value that we want to consume in the next chained then method. So this data parameter is going to get the value of whatever read file promise returned when it called resolve with the data. And all we're going to do here is just print that information to the standard output. Finally, we want to clean up this unnecessary file that we've created here. So we've got another then clause that is going to invoke fs unlink promise. And that's going to invoke the promisified version of the unlink function and throw the file away. And then notice here at the end, we haven't been doing very much with error handling so far. We've just been kind of stringing one thing to another. It's a very common idiom when we're using promises to just leave the error handling to one catch method at the very end of this. So if there has been a problem in any of these chained .thens, the effect is going to be that the JavaScript engine is going to eventually call this .catch method, and it will invoke our function that we've provided here. And because the .catch is going to be invoked when we call the reject method inside of our promisification with a particular variable that's often going to be an error object, we're going to be given that error object here in the .catch inside of our fat arrow function that we pass to catch. And in this case, I'm calling console.error and printing out the contents of that error message. And then when that's all done, finally I've got console.log completed. So we can run this thing by calling make a promise, right, the name of the top level function, pass in the file name, pass in the starter value of 42, and we get this output. Now, of course, it's going to be in a little different order than may be obvious at first, because the code is going to kick off this very first asynchronous operation, fs write file promise, and then basically fall through right away to this next instruction and execute it immediately. Meanwhile, all of these asynchronous operations are going to be going on behind the scenes, and after they complete, assuming they complete successfully, we'll see the output that's coming from that console.log statement, which shows up as 4284. One other thing I want to point out here with respect to this example, whenever we make a new call to one of these asynchronous promise wrapper functions like append file promise or read file promise, they're going to return a brand new promise. So the fs write file promise, right, we saw that is going to construct a promise and then associate the appropriate behavior with writing a file. And the top level of all of those promisification functions was returning a new promise, okay? That's important to keep in mind, that it's a brand new promise that comes back from each of these functions. So fsWriteFilePromise returns a promise, and on that promise, we're calling .then. The behavior of .then is going to be to call this function that we supplied so that we can kind of inject our own code into the sequence of asynchronous calls and have it do the next step. But then append file promise, if we go back here and find that, right, this guy also returns a new promise. So the promise that's coming back from this second step in the process is going to be a new one created by append file promise and interpreted by the then that's going to then do the read file eventually if everything worked okay. Okay, so it's important to keep in mind that there's a new promise showing up each time, and that's really what gives us the ability to kind of string together these multiple .thens. It kind of looks like there's one promise kind of filtering down, but that's not really what's going on. We call the promisification function, it does its thing, returns a promise, then when the .then gets invoked on that promise, it's going to do a new invocation, in this case of some asynchronous behavior, and return a new promise. So it's kind of promises all through this list, but there's a new promise created each time. Then finally, the behavior of this .catch clause, if we wanted to, we could actually run .catch at various places along this chain. I could say write file promise .then do something, .catch do something, and that would take care of errors in that very first promise. In contrast, if we leave the error handling until the very last here, like we've got in this example, the way that works is that each of the intermediate .thens checks inside the promise to see if it had been rejected previously. In other words, if something has gone haywire earlier in this chain of .thens, that .then will not invoke our callback function. It's going to just skip out to the next .then in the sequence, and then each of those intermediate .thens are going to just pass along that error state until it finally hits the .catch, at which point the callback for the .catch will be invoked and our error will be reported or handled or whatever the catch does. So it's entirely up to you whether you want to include .catches along that chain to maybe do different things based on whether something went wrong at a certain point in the chain of asynchronous operations, or if you want to just kind of finesse it by saying, hey, I'm going to assume that this is going to work the lion's share of the time, and I'll just do one .catch here at the end to make sure that I'm catching any sort of an error, and at least it's not going unnoticed. So that's a best practice, is to always include at least the one .catch at the end, and if appropriate, if there's something you can do about it at other places along the way, then you can include .catches elsewhere as well.